Welcome to Interior Angle Theorem. So the angles that we're going to look at are inside the circle, and they're formed by two intersecting chords. Sometimes they're called chord angles. Right? Not to be confused with our central angles, right, that were formed by two radii. These are formed by two chords. Right? So they are inside our circle here. And if we look, we see that angle 1 has to be congruent to angle 2, right? Because they're vertical angles. But notice that their arcs, arc AC, is not congruent to arc DB. And angle 1 and angle 2 aren't equal to arc AC or arc DB either. Right? So, although angle 1 is congruent to angle 2, arc AC is not congruent to arc DB. Right? The only way that angle 1 and angle 2 and arc AC and arc DB would all be congruent is if angle 1 and angle 2 would have to be central angles. So their vertex would have to be at the center of the circle, not just somewhere inside the circle. And the sides would have to be radii. Sides formed by radii. So if that were true, then angle 1 would be equal to angle 2, and they'd both be equal to arc AC and arc DB. But that's not true, right? This is not a central angle. Its vertex is not at the center, and they're not formed by radii. Those are chords. So for angles that are inside the circle, but not at the center, the measure of the angles formed by the two intersecting arcs is going to be equal not to either one of the arcs, but rather to the average of the arcs, half the sum of the measures of the intercepted arcs. So angle 1 is not going to be as large as arc AC, and angle 2 is not going to be as small as arc DB. They're both going to be equal to the average of those two arcs. So here, angle 1 and angle 2 would be equal to 75 plus 29 divided by 2. So that would give us 104 divided by 2, which is 52 degrees. So both of these angles here are 52 degrees, the average of those two arcs. All right, so here, to find the measures of our angles inside the circle formed by chords, we're going to take the average of the two intercepted arcs. And so, by the way, this was in your notes because, you see, it has notes there. And it'll take so long to change the page, you can probably fill in the notes while we're waiting. There we go. All right, so angles formed inside of a circle by two intersecting chords. So angles formed inside by two chords is always going to be equal to half the sum of the intercepted arcs, the arcs for the two vertical angles. So when two chords intersect inside a circle, 4 angles are formed. At the point of intersection, we have two sets of vertical angles, right? We have angle CEA and BED, which are congruent to one another. And then we have angle CEB and angle AED, which are also congruent. Maybe I'll put that in another color so you can see it. All right, so we have those pairs of vertical angles. And actually, once we found one of the measures of the angles that are formed by this intersection, we actually know the measures of all 4, because we have two pairs of vertical angles, and the vertical angles are congruent, and we have 4 pairs of adjacent angles, and the adjacent angles are supplementary. They add to 180. So it's really easy to find the measures of these angles because we don't need a whole lot of information before we know all of the angles. Right, so we're going to add the intercepted arcs together to find the measure and divide by 2. Right, so if we want to find the measure of angle BED, which is the exact same measure as angle CEA, I'll just put also angle CEA, all we have to do is add those two intercepted arcs, right? And so if you follow the angle out, so if you follow angle E from the vertex out to point C, and from E out to point A, there's one of the intercepted arcs. And if you follow the other angle, from E out to point B on the circle, and from E out to point D, here's the other intercepted arc. All right, so that's going to be equal to 1/2 of 170 plus 70. And you can write it like that, or you can put divide by 2. It's the exact same thing. So that's going to be equal to 1/2 of 240, which is 120 degrees. So this angle here is 120 degrees. This angle here is 120 degrees. Notice the arcs are not 120 degrees, just the angles. And then if we wanted to find the other two angles, all we would have to do is subtract from 180. So angle CEB CEB is congruent to angle AED. Okay. And they're both equal to 180 minus 120, or 60 degrees. So those here are 60 degrees because they're supplementary. Right? So now we've solved this one. Right? So we'll be dealing on this one with using the formula for angles inside the circle, and also working with linear pairs if we're looking for the adjacent angles. And here comes the next one. Right now, maybe. Just waiting for the page to turn, and then we'll solve a problem. There we go. All right, so we're going to find x and y here. All right, so x here, it's this angle right there. We see its intercepted arc is between those 2 points. Right? The vertical angle is right across from it, and that intercepted arc, if we follow that angle out, is between those 2 points. Right? So here are the 2 intercepted arcs. So that means x here is going to be equal to 1/2 of 80 plus 40. So that means x is 1/2 of 120, which is 60 degrees. Now, if we want to find the measure of y, right, we don't need the arcs, right, because we have a linear pair. X plus y, angle x, or whatever it is, plus angle y is equal to 180 because they form a linear pair. Right, so we know x is 60. And it's kind of like the other problem on the other page. If we subtract 60 from both sides, y is 120. And this is probably in your notes because it says notes up there. I don't have the notes in front of me. And there we go. That's all there is to it. I think the trickiest thing about these problems is remembering, you have to remember your formulas, right? And you have to remember, you have to think about, you can't just solve these blindly. You have to think about, is the vertex of the angle at the center? Clearly it's not, because the center is that big black dot there. Is it on the outside of the circle, or is it inside the circle? And once you know where your vertex is, what kind of angle it is it inscribed? Is it a chord angle? Is it a central angle? Then you can use the right formula. And turning the page. We have another problem. I think there's like 6 of them. Yeah, I'm sure I'm going to hit the page before I want to turn it because it takes so long to turn the page. There we go. All right, so same kind of problem, just a little bit harder, right? Because here's our angle, right? So we can follow that out to its arc right here. So just a little harder because it has algebraic expressions to work with, but the steps will be the same, right? And then if we follow this angle out to its arc, right, it's right there. So here are the two intercepted arcs. And that means that our angle there, this time we know the angle, we just don't know the arcs. But we have something to stand in for the arcs, right? Those algebraic expressions. That angle there is equal to the arcs divided by 2, or times a half, right? So 1/2 of, and actually I'm going to write this one as divide by 2. And I have a reason for that. I just think it'll look nicer on this problem. 3x plus 3 plus 10x minus 14 divided by 2. All right, now I could combine like terms, but I'm not going to right now. I could divide everything by 2, but I'm certainly not going to do that. I'm going to get rid of the 2. How do you get rid of the 2? What's the inverse of dividing by 2? Multiplying by 2. So we're just going to multiply both sides here by 2. And that will cancel that out there. And so now if 53 is equal to half of the sum of those angles, 106 is going to be equal to exactly what those arcs equal. So we have 106 equals 3x plus 3 plus 10x minus 14. We'll add our like terms together. 106 equals 13x minus 11. Right? And then we'll get everything on one side. Get our numbers on one side, and then our variables on the other side, and then we can just divide both sides by 13. So we'll add 11 to both sides, so we have 117 equals 13x. And actually, if we multiply, so 13 times 9 would be 90 plus 27. That's 117. So if we divide both sides by 13, x is equal to 9. Right? And that's all we had to do. Right? So on these, really it's the exact same steps. It's just instead of just numbers, we're dealing with algebraic expressions. And you want to isolate that algebraic expression by multiplying both sides by 2 so that you don't have to deal with the dividing everything by 2. That would not be as easy a problem, and you might have some weird decimals or fractions to deal with. And you see this was a really easy solve. Right? So all we do is we just follow the angles to their arcs, add up the 2 arcs for those 2 vertical angles, and divide by 2. We're taking the average. That's the hardest problem I think on here was this one. And it's just because it was an algebraic expression to solve, not because the setup was particularly difficult. And we're turning the page. I don't think there's too many more of these left. Right? I think there's 1, maybe 2, and I think that might be it. Maybe just those 2. Let's find out. Yeah, just those 2. So let's do one more. I'll save that last one. Oh, no, I have 3. Sorry, they look so much alike. I'll do this one, and then maybe we'll do the next 2 in class. And we'll look at the last angle relationship. All right, so here, very, very similar problem to the last one. All right, here's our angle. Right, if we follow the angle out, right, it's going to be equal to half of the sum of those 2 intercepted arcs. So 48 equals y plus 2y plus 3 divided by 2. I don't want to divide by 2. I'm going to multiply everything by 2. So I've got 2 times 48 equals y plus 2y plus 3 divided by 2 times 2. That will cancel that 2 out. So I have 96 equals y plus 2y plus 3. We'll add our like terms together. 96 equals 3y plus 3. Subtract 3 from both sides. We have 93 equals 3y. And if we divide both sides by 3, y is going to be equal to 31. Right? And that's all there is to it. Okay? And you can even plug it back in and check and make sure. Right? So if I were to plug it back in, this would be 31 over here. And this would be 2 times 31 plus 3. Right? So that's going to be 65. Right? 62 plus 3 would be 65. And if I add that together, 65, so here's my check. So if I'm not sure, I don't want to check my work, I can always just plug it back in and see. If I add them together and divide by 2, do I get 48? So 65 plus 31 divided by 2, is that 48? Well, that's going to be 65 plus 30 would be 95, so add one more, it's 96. 96 divided by 2, and that indeed is 48. So that checks, oops, that's a funny looking for, that checks out. So the checks are not required, but if you want to see if your answer works out, you want to check your work, you could always plug it back in and make sure that the sum of those two intercepted arcs divided by 2 equals your vertical angles. Okay? All right, so we're going to do the last 2 problems in class, and in the next podcast, we're going to look at one other type of angle relationship. All right, so the angle's been the vertex has been on the circle, it's been at the center of the circle, it's been somewhere inside the circle. Where else is there to go but outside the circle? Right? Angles outside the circle coming up next. Right? Bye.